This was in 2003. And the 12 principles of green engineering outlined what would make a greener chemical process or product. The principles include durability, rather than immortality, output pulled versus input pushed, conserve complexity, meet needs, minimize excess principles. I will take the first one there to just talk about it. The principle here emphasizes the importance of designing products with a specific lifespan or durability in mind, rather than aiming for indefinite or immortal lifespans. These approaches aligned with the principles of green engineering, which prioritize sustainability and minimizing waste. Designing products with targeted durability involves considering factors such as the intended use of the product, the materials used for its construction or manufacturing, and the environmental impacts of its production and disposal. So by setting a specific lifespan for a product, designers of chemical processes can ensure that it is built to last and for its intended purpose without being over-engineered or wasteful. So this approach basically allows for more efficient use of resources, as products can be designed to be easily disassembled and recycled or repurposed at the end of their life span. The other principles of green engineering include inherent rather than circumstantial, prevention instead of treatment, design for separation, and maximum efficiency principles. The first one, the principle of engineering here emphasizes the importance of using renewable materials and energies resources instead of the depleting ones. We know that renewable materials are those that can be replenished naturally or through sustainable practices. Similarly, renewable energy sources are those that can be replenished naturally or through sustainable practices such as solar, wind, and hydropower. So in contrast, depleting materials or energy sources are those that are finite and will eventually run out, such as fossil fuels like oil and coal. So by using renewable materials and energy sources, we can reduce our reliance on those finite resources and minimize the environmental impact of our activities. So this can help to mitigate things like climate change, reduce pollution, and of course, promote sustainable development. However, it is important to note that not all renewable materials and energy sources are created equal, and some may have their own environmental impacts or trade-off. Therefore, it is important to carefully consider the sustainability of different options and choose those that are truly renewable and sustainable in the long run. These are the other four green engineering principles. However, permit me to skip them for sake of time, please. Let's look at the benefits of green chemistry. Here, I will attempt to highlight some of the advantages and benefits of implementing green chemistry principles. Embracing green chemistry principles offers a range of benefits that could potentially contribute to a sustainable and healthier future. include cost effectiveness, health, safety. Let's look at health and safety here. Green chemistry promotes the development of safer chemicals and processes, reducing our risk, humans' risk to occupational, reducing risk to human health and occupational safety. It minimizes exposure, say, to toxic substances, harmful chemicals, both for workers and the end users of products, improving our overall well-being and enhancing sustainability. So by implementing green chemistry principles, researchers, industries can actually ensure compliance with current and future regulations. Let's look at some of the applications of chemistry. Green chemistry has numerous applications across industries, including pharmaceuticals, agriculture, energy, and materials. For example, pharmaceutical industries now focus on developing drugs using environmentally friendly methods and greener solvents. Reducing the environmental impact of drug manufacturing. Of course, say in agriculture, the use of biopesticides and eco-friendly fertilizers helps maintain ecosystem balance. Furthermore, green chemistry plays a very critical role in the development of cleaner and more efficient energy sources, such as biofuels and solar cells. So the word metathesis means change places. It can be compared to, say, a dance in which you have two couples or a couples change partners. In metathesis reactions, double bonds are broken down and made between carbon atoms in ways that cause atoms groups to change places. This happens with the assistance of some special catalyst molecules. And the first person that actually looked at this process was Ives Chauvin, a French chemist, though later right now, he was the first to propose the concept of metathesis as a reaction involving the exchange of alkaline moieties in olefins mediated by metal complexes. His insightful theoretical work in the 70s earned him the Nobel Prize in Chemistry in 2005, which he shared with two other American laureates. That's Richard Schrock and Robert Gross. This process, that's metathesis, has found diverse applications in the chemical industry, mainly in the development of pharmaceuticals and of advanced plastic materials. Some notable applications include pharmaceutical synthesis. Here, this was utilized in the synthesis of drug molecules, offering efficient and atom economical routes to complex pharmaceutical compounds. In polymer chemistry, it was utilized for the creation of advanced materials with controlled structures and properties, leading to novel applications in industries. It has also been instrumental in the synthesis of natural products with challenging structures, offering an eco-friendly alternatives to traditional methods. So metathesis in a way has also played a role in the production of biofuels from renewable energy sources, contributing to the development of sustainable energy solutions. Please, just a moment. Let me take a moment. Thank you. So, thanks to the aforementioned laureates' contributions, synthesis methods have been developed, that's talking about the metatheses, have been developed that are more efficient these days. They're simpler to use, and they are also environmentally friendly. These represent a great step for green chemistry, reducing potentially hazardous waste through smarter production. So metathesis, in a way, is an example of how important basic science has been applied for the benefit of man, society, and the environment. Green chemistry has played a significant role also in revolutionizing the manufacturing processes of computer chips, also known as integrated circuits. The semiconductor industry, which produces computer chips, has adopted various green chemistry principles and sustainable engineering practices to reduce environmental impact, minimize waste, and improve energy efficiency throughout the manufacturing lifestyle. To manufacture something, say, like a computer chip, many chemicals, large amount of water and energy are usually required. In a study that was conducted in 2003, the industrial estimate of chemicals and fossil fuels required to make a single computer chip was put at 6:1 ratio. That means that it takes about 630 times the weight of a chip in a source material just to make one particular chip. That's quite humbling. Compare this to the 2:1 ratio for the manufacturer, say, of an automobile. So scientists at the Los Alamos National Laboratory developed a process that uses supercritical carbon dioxide in one of the steps of chips preparation, and it significantly reduces the quantities of chemical and energy and water needed to produce chips. Of course, this was the application of a green chemistry principle. This was a new method for processing semiconductors wafers, and of course, it is still in use today, leading to the production of non-flammable, non-toxic, environmentally friendly solvent, which of course reduces water greatly and cut the volume of hazardous waste produced as a result of computer chip. Green chemistry has also found application in a new breed of circuit board developed from chicken feathers. You wouldn't even believe this. Richard Wood, a former director of Affordable Composites from Renewable Sources program. This is at the University of Delaware. He found a way to use chicken feathers to make computer chips. The protein keratin in the feathers was used to make a fiber form that is both light and tough enough to withstand mechanical and thermal processes. The result was a feather-based printed circuit board that actually works at twice the speed of traditional circuit board. Although this technology is still in progress, it's still in the works for commercial purposes, the research has led to other uses of feathers as source material. So I'm here at this point, because I'm challenging the students that are listening to me to look at how they can make use of these principles. And of course, we have lots of chicken weather waste that does thrown away into the environment. Let's see how we can make use of these and to come up with something that's environmentally sustainable. Other uses of feather include production of biofuels. Of course, this has been widely reported as indicated. I know that your university has done quite a lot because I checked online concerning these the use of biosources to produce either biofuels or biodiesels and all of that. The Skyval data that I sourced revealed, of course, I would say it was quite encouraging. These shows the Skyval data for research conducted in Lautech between 2018 and 23. As can be seen here, there are about 65 published papers indexed in Scopus by researchers from your institute, or that's from your university. I want to say that this is quite commendable. You should keep up with this. Looking at the first topic, cluster, that's T16. This is another Skyval data that I have vested with those conducting research on the microbial fuel cells, anaerobic digestions, bioreactors. We have about 35 publications. These are the most active, these are the top 5, the top 10 authors from your university that are focusing on this topic cluster. And I want to say that, well, this is quite encouraging, but there's more to be done. It's a good start, but you can do more on this. Again, I tried to look at zoom down on the number of articles, the number, of course. I wanted to know how many papers are actually, articles, whether the review papers and all of that. From my analysis, I found out that about 18 or 17 rather papers were published. These are actual research, and about 11 review papers were also published during this period, with about 6 conference papers. And then, of course, one publication in the book chapter. This is, again, encouraging. I just want to urge the authors or researchers in this area to do more about this. And then for those that are focusing on the topic cluster 165, that's on biodiesel. I saw about 21 scholarly publications by these authors. These are the top 10 authors at your university that are focused on this topic cluster, and these are their research outputs. Again, it's quite encouraging. I want to urge the lead authors here, those that are leading the pack here to I mean, they should do more. It's a good start, I must say. It's commendable, but you can do more. This is a breakdown by publication types. I'm not going to just waste my time on this. I'll move on to the next application. Green chemistry has made significant contributions to the pharmaceutical industry by promoting more sustainable and environmentally friendly methods of drug manufacturing. By employing safer and greener solvents, efficient catalysis, renewable feedstocks, process intensification or optimization, and biocatalysis. Pharmaceutical manufacturers have been able to reduce waste generation and minimize their environmental footprint. So as the principles of green chemistry continue to evolve, Pharmaceutical industry is continually, of course, they are seeking ways to develop medicines with less harmful side effects and using processes that are less that produces less toxic waste. Typical examples are as follows. We have Make and Codices. Codices is a biocatalyst company based in the US. They collaborated to develop a membrane synthesis process for the production of sitagliptin. This is used for the treatment of type 2 diabetes. This collaboration led to an enzymatic process that reduced waste, improved yield, and of course eliminated the need for a metal catalyst. This process has the potential to be used for the manufacturing of other drugs as well. Again, Professor Tang of the University of California created a synthesis for simvastatin. This is a medication for the treatment of high cholesterol using an engineered enzyme and a low-cost feedstock. He was able to optimize the enzyme and the chemical process, resulting in a cost-effective method that greatly reduced hazard and waste. Other applications of green chemistry includes the development of biodegradable plastics or bioplastics. The application of green chemistry principles and sustainable engineering practices. Researchers can successfully synthesize bioplastics that can break down into harmful substances, thereby reducing pollution. And of course, this also tends to promote environmental conservation. These are some of the examples of how green chemistry has been used to manufacture bioplastics. For the sake of time, I may not just want to look at all of these and explain them one by one, but I'll just skip through this. When I share this slide, you can just go through them. So we look at the other principle or application here, the application of green chemistry for the production of bio-based paints. Oil-based alkyd paints give off a very large amount of VOCs, that's volatile organic compounds. These volatile compounds evaporate from the paint as it dries and cures, and many have been known to have very serious environmental impacts or consequences. Green chemistry has driven transformative changes in the paint manufacturing industry, leading to the production of more environmentally friendly paints. So by adopting, say, water-based formulations, incorporating bio-based ingredients and green pigments, using biodegradable additives, minimizing waste, focusing on low energy manufacturing. Paint manufacturers are making sufficient strides towards sustainability in this way. So here are some examples of how green chemistry has been used to produce paints. First, we look at water-based paints. We know that the traditional solvent-based paints use volatile organic compounds as solvents, which contribute to air pollution and pose health risk. Green chemistry has encouraged the shift towards water-based paints, which use water as the primary solvent instead of the harmful organic solvent. So let me point out that water-based paints have very low VOC emissions, reducing their impact on indoor and, of course, outdoor air quality. They also enable easier cleanup and disposal of unused paints. We know that Sherwin-Williams developed, this is an American paint company based in Ohio in the US. They developed water-based acrylic arcade paints with low VOCs that can be made from a combination of recycled soda bottle plastics, that's the paint bottles, acrylics, and soybeans. These paints combine the performance benefits of the alkyds and the low VOC contents of acrylics. I mean, in 2010, this company manufactured enough of these neoprens to eliminate over 800,000 pounds of VOCs. Also, bio-based ingredients can be introduced to produce bio-based pens. I may not want to just spend my time on these again because my time is fast spent. Other applications include other considerations of green chemistry in biopens. Bio-based pens production include the development of eco-friendly green pigments, biodegradable additives, waste minimization, low energy manufacturing, and eco-friendly packaging. I will skip this discussion for the sake of time, please. Let's look at the other principles or the other applications rather. Green chemistry again offers innovative solutions to address the challenges in water treatment, ensuring access to clean and safe water, while minimizing environmental impact. We can explore these treatment processes, but permit me, for the sake of time, I would just do justice to just one of them. And permit me to take the first one. Green chemistry solutions have come to the rescue by promoting the use of natural or alternative coagulant derived from plant-based materials such as chitosan and tannins as alternatives to traditional chemical coagulants like things like alum sulfate. These natural coagulants are biodegradable and they are non-toxic, and they have comparable or improved coagulation efficiency. The AOPs, that's advanced oxidation processes such as photocatalysis and ozonation, utilize environmentally friendly oxidants such as hydrogen peroxide or ultraviolet light to degrade organic pollutants in water. These processes minimize the formation of harmful disinfectant byproducts, and of course they also tend to reduce chemical usage. And the benefits achieved include reduced environmental impact, improved water quality, and prevent exposure to harmful chemicals, as well as minimize risk that are associated with waterborne diseases. Green chemistry has played also some critical roles in addressing the challenges of greenhouse gas emissions, which of course contribute to climate change and environmental degradation through the development of sophisticated carbon capture technologies, efficient catalytic processes that minimize energy consumption, as well as promote the use of renewable feedstocks such as biomass or carbon dioxide as alternatives to fossil-based feedstocks. It has also found applications in fields such as energy storage, sustainable materials development, waste management, and sustainable agriculture. I would have loved to explore how green chemistry is revolutionizing these fields and present them examples of green chemistry solutions. Our time is fast spent already. Permit me to move on and show you your university's contributions to green chemistry and sustainability engineering research on other topic clusters. This is what you have done so far, and I must say it's quite commendable. I conducted Skyval analysis between 2018 to 2013, 2023. The researchers at your university have contributed to about 423 topic clusters, and of course about 924 topics. Notably, researchers related to green chemistry and sustainability engineering, such as nanoparticles, those that are conducting research on silver nanoparticles, green synthesis, biofabrication, bio suction, and biodiesel production, take a commanding lead, as can be seen here. You have the topmost here is about 60 scholarly output, and this is followed by about 53. This is university-wide, and of course, those in nanofluid actually, talks about or have about 22 research publication. This is quite commendable. Let me commend all the researchers that are working in these areas. But again, there's still more work to be done. These are some of the, this is the list of the first top 5 researchers in the university conducting research in green chemistry-based topic. And the topic, this one is topic 161. That's silver nanoparticles, green synthesis and biofabrication. Our breakdown shows that out of 60 publications, 32 are actually articles. This is good, and about 18 conference papers part of the publication types. That's we have Latif A and the others. Again, this is the first top 5 researchers in your university conducting research in green chemistry-based topic TC1, that's topic cluster 191, and that has to do with absorption, absorbance, activated carbon. Let me commend all the researchers working in these areas. There's still more work to be done. We have Bello, Professor Bello, and others. This is quite good. I mean, you should keep up the good work, and you need to, publish more on this field. Let me even actually say this. When I looked up, when I compared this with some other universities, leading university back out there in Nigeria, your university is doing quite well, and this is highly commendable. I think you guys deserve a round of applause for this. Let me go into something quite, I know that this is going to be a little bit controversial, but AI has come to stay and will influence the way we do things, including our research and products development. AI has the potential to revolutionize research in green chemistry and sustainable engineering, offering innovative tools, methodologies that can accelerate progress towards a more sustainable and environmentally conscious future. So I'm thinking that by leveraging AI's capabilities, researchers can gain deeper insights, optimize processes, and design more eco-friendly materials and technologies. Believe me, AI, like I said, has come to stay and will influence all that we do, including our research and products development. It is my view that we should catch up with this, so that as AI continues to advance, it will reshape the landscape of our research and drive transition towards more environmentally friendly and sociable responsible practices. Here are some ways that I think AI can reshape research in green chemistry and sustainable engineering. And of course, I urge that we should just tap into this. First is the predictive modeling and simulation. AI-powered predictive modeling and simulation techniques, algorithms, if harnessed, can enable our researchers to analyze complex chemical reactions and materials at the molecular, even at atomic levels also. These will allow them to predict the properties and behaviors of new compounds and materials without the need for some extensive experimental testing. researchers can use this information to design materials with specific attributes, such as high strength or biodegradability, thermal stability, etc., tailored towards sustainable engineering applications. So by reducing the trial and error approach, I think could help us expedite the discovery of greener alternatives and more sustainable solutions. Another one is the virtual screening of chemical libraries. I will take only two for the sake of time, please. AI, I know, can help analyze vast databases of chemical compounds and predict their properties, enabling virtual screening to identify potential green alternatives. This could accelerate the discovery of eco-friendly materials, catalysts, and chemicals, thereby reducing the need for resource-intensive and time-consuming experimental testing. Probably, maybe I should take this last one here. AI does a de novo molecule design. AI can generate can help us generate novel molecular structures that meet specified criteria, such as low toxicity and high efficiency. So this capability could enable, for instance, the creation of green solvents, polymers, and additives, fostering innovation in the development of sustainable processes. As I begin to conclude, green chemistry and sustainable engineering stands as a beacon of hope in the journey towards a more sustainable and environmentally conscious future. The emergence of these disciplines, I know, has brought about a fundamental shift in how we approach chemical processes, materials development, and proffering engineering solutions. As the world faces ever-increasing environmental challenges, the principles of green chemistry and sustainable engineering have shown their potential to change research products or revolutionize research products and pave the way for a cleaner, greener, and of course, a more sustainable world. So today, green chemistry and sustainable engineering have already found applications. Of course, I have highlighted some of them in the fields of medicine. This principles have been able to the production of safer and more eco-friendly drugs. The synthesis of biodegradable plastics made possible through green chemistry offers a promising alternative to conventional plastics. Of course, this will help us in combating plastic pollution and ultimately protect our marine and freshwater ecosystems. Alternatively, or additionally, the development of renewable energy sources such as biofuels and solar cells showcases the transformative power of sustainable engineering in our fight against climate change. The impact of green chemistry and sustainable engineering is not just limited to individuals and researchers or discipline. I want us to get this, please. Rather, it should be seen as a catalyst for cross-disciplinary collaborations. I must even admit the fact that when I looked up the cross-section of authors from your institution, of course, I took some sample papers and I looked at a cross-section of the authors. I was really pleased with the kind of interdisciplinary natures of the collaborations that I found. In my view, I think this should be encouraged. These principles should foster cooperations among chemists, engineers, biologists, environmentalists, policymakers. Of course, we can incorporate people from the town. Let them come merge, and of course, with the gown. They should be able to provide funding for research, and of course, we can have a collective green chemistry and sustainable engineering hold immense promise. So as technology advances and research continues to expand, we should expect more innovative applications. The development of efficient and scalable catalyst, the utilization of artificial intelligence, just like I mentioned earlier, in chemical design, and the integration of principles in material science are just a few examples of the exciting possibilities on the horizon. However, it is my considered view that for a successful implementation of green chemistry and sustainable engineering, these should rely on a collective commitment and action by all government, industries, individual, that's talking about researchers in the academia, must collaborate to support research, development, and the adoption of sustainable practices. Policy initiatives, funding for green innovations, public awareness campaign are essential to help us drive the widespread adoption of environmentally friendly solutions. Green chemistry and sustainable engineering offer a blueprint for building a better future. So by embracing these principles, address environmental challenges, we can mitigate climate change and, of course, foster a sustainable global society. The journey towards a greener world is ongoing. And with dedication and collaboration we can harness the power of green chemistry and sustainable engineering to create a brighter and more sustainable future for generations to come. Finally, the scientists all over the world have been able to develop, they have done something concerning green chemistry. I must commend, the faculty or the staff in your university for what they are doing. But like I said, we can do more. We can create more alternatives to hazardous substances. We can design more chemical processes that reduce waste and reduce demand on our diminishing resources. We can employ processes that use small amount of energy. We can do all of these and still maintain economic growth and opportunities while providing affordable products and services to our growing world population. This field, that's green chemistry, is a field that's open for innovation, new ideas, revolutionary progress. I believe this is the future of chemistry. This is green chemistry. These are my references. I want to give thanks to the Almighty God for this opportunity. Of course, especially thank the organizers of the 2023 Avant Garde conference. I want to thank the acting vice chancellor of LAUTECH, the head of the department, Pure and Applied Chemistry, and then also acknowledge my chairman, chairman of ACS Nigeria, Professor J. Obaleye. I want to also thank Professor Esther Onawumi and Mr. Ojo Shegun Samson. This was actually the link that made this possible. And also, I cannot forget my my late mentor, Professor Abaz Olajere, who was of course incidentally, he was my mentor, and of course from your institution. I want to remember him also. I want to thank everyone for your attention. I would now be happy to answer any questions that you may have. Thank you.
Thank you very much, sir, for that beautiful lecture. We really appreciate you. Now we want to go into questions, both physical here and those online. Please, if you have any question, please, you want to entertain question now. If you have any, the online followers, questions. If you have questions, you can put it across to us. We are going to read it out. Now we have like 3 questions here. Can you hear me, please? Sir? Okay. Now, the first question, understanding the environmental impact of chemical processes throughout their entire life cycle is essential for green chemistry. I want to ask about methodology and tools used for life cycle assessment and how this assessment can guide sustainable decision making. Yes, that's the first question.
Please, can you come again with the question? It's echoing.
Okay, the second question. Green
The first
chemistry.
question.
The first one. Okay, I should repeat it.
Yes, sir.
Understanding
Thank
the
you.
environmental impacts of chemical processes throughout their entire life cycle is essential for green chemistry. I want to ask about methodologies and tools used for life cycle assessment and how the assessment can guide sustainable decision making. Now we are expecting the feedback, sir. Okay. Let me move to the second one. Green chemistry emphasizes the I can't get the question very clearly.
Green chemistry emphasizes the reduction, reuse, and recycling of waste materials. I want to know about the techniques and technologies being explored to minimize waste generation and convert waste into valuable resources like biogas, electricity generators. And third question, I do think integrating renewable energy sources effectively into chemical processes can be challenging. Currently, is there any barriers, advancements, strategies being developed to overcome these challenges, if there is? Okay, the third question. I do think integrating renewable energy sources effectively into chemical. I do think integrating renewable energy sources effectively into chemical processes can be challenging. Currently, is there any barriers, advancements, strategies being developed to overcome these challenges, if there is?
Please, I don't know whether you're hearing me. You are breaking. I was only able to get the first question, the second question, and the third. I cannot. If you're hearing me clearly. So, but I can go ahead and answer the first one if you're hearing me.
Yes, you can answer the first question, sir.
I couldn't get the second, please.
Okay.
And of course, the last one there. Okay, so thank you for your question. I think that has to do with life cycle assessment. First and foremost, I want to probably throw more light on what life cycle assessment is all about. This is a crucial tool in green chemistry that is used to evaluate the environmental impact of products and processes through their entire life cycle. So life cycle assessment, or what we call LCA, helps researchers and industries to make informed decisions to minimize environmental burdens and promote sustainability. He asked about the tools. So there are several tools that can be used for conducting LCAs in green chemistry. I will mention just a few of them. You can use Sigma Pro. This is widely used commercial software for looking at the LCA assessment in green chemistry. It offers a comprehensive set of tools for conducting LCA studies, allowing users to model different LCA cycle stages. We can also define impact categories and assess environmental impact. The second one is GABI. GABI is spelled GABI. This is developed by ThinkStep. This is another tool that can be used. Of course, it's a very popular commercial LCS software. The other one is EcoInvent. This is widely recognized database of LCA inventory data maintained by the Swiss Center for LCA inventories. Researchers and practitioners often use these databases in LCA studies to assess detailed environmental data for various products. We also have the OpenLCA. We also have the Sigma Pro, other Sigma Pro related tools. So you can look them up. Some of them are free, some of them are not free. So you need some paid subscription for this. Hello?
Yes, are you through with the first question, sir?
Yes, I'm done. I've mentioned the tools that Sigma Pro, you have Gabi, you have Open LCA, you have EcoInvent, you have Sigma Pro related tools, a couple of others. Like I said, some of them are free, some are, of course, you have to pay. You need subscription for paid subscription for this. I couldn't get the other questions, please.
Okay, sir. Good. Let me try to read another question.
Thank you.
Now, under artificial intelligence, green chemistry, and sustainable engineering, I want to ask you to kindly explain how an AI can be used to predict modeling and simulation of drugs.
Okay. Okay, so we look at basically we can harness the power of AI to simulate or kind of predict some complex chemical reactions, and then of course look at what the likely products or the desired products are. I I it will the process of developing the model of course will vary depending on what you're looking at. This set of algorithms, of course, it will certainly be based on algorithms, and of course if harnessed properly, it can assist researchers to analyze complex chemical reactions and materials at, like I mentioned, at the molecular or atomic level, such that you can predict the probable properties and the behaviors of your desired compounds. That should be your new compounds or materials, without going through the need for, say, some experimental or extensive testing in the laboratory. So you have to develop first your set of algorithms. I know that this does not it's not even in existence as we speak. I am actually trying to see we can develop this. We can come about something that can actually predict or model, simulate complex chemical reactions, and of course, predict what will likely be our desired output. And so I'm challenging the youths out there who are listening to me, the young ones there. Think about something. Come up with it. Of course, you can be there making millions, millions of dollars or euros per day. People couldn't tap into your algorithms, and then of course make you'll be there just seated in the comfort of your room. You're making millions. These, I must say, it's a futuristic kind of perspective, something that I'm thinking should be done. Of course, you can come up with something, and then you make serious euros, out of this. I don't know whether that helps.
Yes, yes. Thank you very much. Another question has been sent to your question port. I want to believe you can see it.
Oh, let me go there.
Okay.
I want to know about the techniques, right?
Yes.
Okay. About the techniques being explored to minimize waste and convert valuable resources like biogas. I'll read the question, please. I want to know about the techniques and technologies being explored to minimize waste generation and convert waste into valuable resources like biogas, electric generators. Okay, thank you very much for this question. Well, we have several, of course, there are several ways that this could be some prominent methods that can be explored. The first one will be, say, the waste to energy incineration. This is a process where non-recyclable waste is bound to generate electricity or heat. And then, of course, I know that these methods, or of course, these waste management systems are not available back out there at home. That's in Nigeria, but in Europe and Americas, they have this. So modern West to energy incineration system or facilities employ advanced technologies to ensure that to ensure efficient combustion, reduce the amount of greenhouse gases that are emitted into the environment. Of course, recover energy from waste that could otherwise end up in landfills. The other one is pyrolysis. Pyrolysis. I think this one is very common. Pyrolysis is a thermal decomposition process that converts organic materials such as say plastics, rubbers, biomass into bio oil, biochar, and syngas. Bio oil can be refined into biofuels, while biochar can improve the soil health and, of course, sequestered carbon. Good enough, I think there are so many very good and very sound researchers in your institution that are actually working on this. Like I showed you in some of the slides. Someone like Latif, I don't know whether he's in chemistry department or whether he's listening to me. He has worked quite well on this topic, and I think whoever asked this question can leverage more on what he has done, learn from him, and of course you can receive a very good mentoring from him. I'm even pleased to mention that I had when I looked through the list of my publication, I remember that I had some form of initial collaboration with him. We have a publication together with late Professor Olajira Abbas. Unfortunately, when he paused, this collaboration couldn't just continue. But you have very sound, very good researchers in your universities that are actually doing something about this.
Thank you very much, sir. We have the last question in the pot, sir. Can you access it, sir?
Okay, let me go there. I do think integrating renewable energy resources effectively into chemical processes can be challenging. Currently, there is a barrier. Advancement and strategies being developed to overcome this challenge. If there is, the question is not complete. That's where it stops. If the challenge, this challenge, if there is, and that's where it stops. So I don't know the question. I do think integrating renewable energy resources effectively into chemical processes can be challenging. Currently, is there any barrier, advancement, strategies being developed to overcome these challenge? If there is, none that I am actually aware of at this point in time. I do not know. I must even mention that I do not conduct research on this field. I see myself as a marine scientist, I would say, and someone who deals with issues of climate change, not necessarily green chemistry. So I don't know of some of these challenges. I don't.
Are you true, sir?
Yes, I'm with you.
Thank you very much. That will be the last question. But before you go, sir, I want to hand over the microphone to Professor Naomi to greet you formally. Thank you very much.
Thank you very much. Well, I want to, on behalf of the Ladoke Excellent University of Technology, Ogbomoso, as well as the American Chemical Society LAUTECH student chapter, we want to thank erudite professor who has just given us a scintillating lecture as the key message for this particular program. Indeed, you can see that the students as well as other participants have really gained a lot. It has passed a lot of information, and of course, it has also encouraged upcoming researchers to do more. Some of the people you mentioned in your work, particularly Professor Amuda, is here with us. He's already seated among us. Professor Teslim Asafa is also in that area. He has done a lot of work in the area of green chemistry. He's one of the key speakers here. So we really appreciate a great work you have just done. We cannot say it more because you have really impacted all the participants in this place. We appreciate you. Thank you very much, and we hope to receive you some other time. Thank you very much.
Thank you very much, Professor. I mean, I think it gladdens my heart to know that some of the professors that I mentioned in the course of my presentation are actually listening. I want to say that you guys are doing a very good job out there. You're trying your very best, I must say. I wish that the young ones listening can actually be humble enough to receive good mentoring from our seasoned expert. You're doing very well, I must say. Like I showed you in your Skyval analysis. But like I mentioned, we still have more work to do. Let's actually get our products, the product of those researches, out to the market. By that I mean we can begin to. I looked at some of the papers. I must say that these are things or researches that are worth really patenting. I don't know what they're doing about that. They should also look at developing or improving on what they have, and then of course look for some form of patenting, and this will be the best for it. I want to appreciate the organizers of this conference for inviting me once again. Thank you. I look forward to more. God bless you all.
Thank you very much. Once again, the participant, I want to thank you for being patient, and I believe you are going to gain a lot from these lectures. Now we are quickly moving on to the second aspect of this program, and I want to call on Professor Teslim Ashafa from Mechanical Engineering Department. Now, this time around, if you have any question after his lecture, if you cannot come out to ask, you can put them down. We are going to do justice to it. Thank you very much.
You do the projection, please. The acting vice chancellor in absentia, the organizing committee, all my senior colleagues here, the students, I welcome you to this edition of the workshop or conference. But before I go, I want to see whether we actually pay attention during the last lecture. And how do I know that? Do I have the microphone, the second microphone? I want 5 students, 3 female, 2 males, to tell me 1 point that you are taking home from the previous lecture. Just one. Can I have somebody to take the microphone, please? Your hands up. If you actually listen, if you were attentive, just tell me 1 point. Just a point. Just 1 point. Nobody listened to anything. Nobody understood anything. Nobody is taking anything home. So we wasted 1.5 hours. Just 1 point, a single point.
Okay, my name is Abdul Malik Salam. Only level student, Department of Piano Black Chemistry. Adoke Akintola, University of Technology of Gumasho. The point I'm taking home is that the computer chips can be made, can be fabricated out from the chicken pools or from the poultry waste.
Is that a point? Yes or no? Okay. Second point, just one, not two. Another point. Oh, don't disappoint now. If you say you are chemistry students, best in the university, isn't it? Are you not? You are not. Oh yeah, let's see. Let's see whether you are or not.
Okay, my name is Ayodele Bayomi Israel, Tronele Piano Applied Chemistry. While he was talking about artificial intelligence with green chemistry, I learned that we are going in the future, we are going to a certain stage whereby we no longer have to think about the molecular structure of a particular drug or substance. We ask or make inquiry from a system designed by human, which is AI, artificial intelligence. Then the integration and the simulation will help we help us to actually live a comfortable life and have an open future for this country or afterlife.
Good. Any other one? Where are the females? Yeah, I know they are topping chemistry at all levels. Am I right? So let's hear from you.
My name is Alabi Aishat from Pure and Applied Chemistry. What I can derive from the conference is that I also like to talk about what is said about the future. We are going to a stage whereby green chemistry will be the backbone for all development in various fields.
All right, chemistry is the backbone, green chemistry is the backbone of everything. Okay, good.
Okay, my name is Precious. Okay, I learned that today that green sustainable energy will help us in the future to produce safe and environmental friendly drugs using traditional methods in agriculture.
Very good. So 4 or 5? We have 5 already, right? 4. Can we have extra one? Okay, good.
My name is Adetunji Priscilla, 211. All I can learn from the short period of time was that green chemistry and sustainable engineering we stand as a beacon for hope and sustainable future. That just as I said, that green chemistry will stand as a backbone for others in the future.
All right, this is good. So to also bring us back, I want all the participants, except my lecturer,
Presentation. Huh? I was in school yesterday and none of you came. I don't know. Hey. Like, I was in school. None of you came up. I don't know. I'll only come to school next week. On Tuesday. I don't know how many of you are left. You were the only one that rushed in that day after we finished. You stay in the house when you are comfort, in your own comfort. We come to school. If we come on Monday,
All right. So the whole essence is man will always carry out one activities or the other. The question to ask is, are those activities endangering our society, our environment? If they are, what are we doing to minimize the negative effects? Or what have we been doing to minimize this negative effect? Because as much as the world remains intact, human beings will continue to do their activities. If you look at 20, 30 years back, especially those who have 4 sets of Ladoke Akintola University of Technology, all around these places, the only thing you have is loud tech. There's no building all around these places. In a span of 20 to 25 years, you have buildings and human activities all over the place. And despite that, you have the positive impact of all this, increase in the economic activities, you also have a lot of negativities attached to it, isn't it? You have pollution, noise pollution all over the place. You have waste and municipal solid waste all over the place, and our environment remains less safer than it was 20 years ago. And that is exactly what the World Economic Forum is trying to tell us. Now, I will start from the fundamental. I'm not going to make it too technical so that you can go along with me. Manufacturing in Nigeria. What is manufacturing? And why is manufacturing important? Look around you. Look around you. Look within yourself. Look up, look down, look to the left, and look to the right. There's absolutely nothing that you see that is not a product of manufacturing. If I tell you, if I start analyzing how this drink came to be, you understand the huge processes that are required to manufacture a product. You have our projector here. If I put them into the pieces, you understand that a projector could contain as much as 200 components. And all those components, each of the components is manufactured through some manufacturing processes. The chairs you are sitting on, they are manufactured. They undergo through some processes. The pen you are holding, the paper you are writing on, the cap you are wearing, the cloth you are wearing, they all went through manufacturing processes. So in other words, manufacturing plays a crucial role in the global economy. And without it, all products we use won't be available. They will not be available. Manufacturing could be anything you think about. Any product you think about, they are all product of manufacturing. Be it in the oil refinery, the cement that we use for construction of our buildings, the food that we eat every day, the beverages and tobacco, the textile, the cloth we wear, the plastic, among others, they are all products of manufacturing. In other words, without manufacturing, there will not be anything. The man will return to the old age. I can tell you that as big as manufacturing is, it contributes about 10.13% to the national GDP as far as 2023 is concerned, according to National Bureau of Statistics. And I can tell you that In monetary terms, manufacturing contributes about 6.61 trillion naira to Nigerian economy in 2022, which is about just 9%. Although it is huge, but it is still far less compared to some of the oil-producing countries like Saudi Arabia, in which manufacturing contributed 124.8 billion naira equivalent, which is how much? As much as 4 times that of the contribution of Nigeria. And don't forget, the population of there is about 30 million. The population of Nigeria is about 200 million, meaning that we are less productive than a country like Saudi Arabia. And then you can see the food processing, the Dangote, all of them. They all contributed so much to the manufacturing process in Nigeria. Next slide. Now, having said that, let's now look at the concept of green manufacturing. Now you understand what manufacturing is. We are producing a product. We go through several manufacturing processes in the workshop, in the factory, everywhere to bring about a product. So what does the green manufacturing, what does it connote now? It means producing products like this drink, using techniques that minimize waste, minimize energy consumption, minimize hazard within the society, and reduce environmental pollution. That is the fundamentals of green manufacturing. So when you hear the word green manufacturing, what are we talking about? We have manufacturing, but a kind of manufacturing that uses procedure that minimize the amount of material that we use, that minimize the waste that we generate, that minimize the environmental disaster that we create, that we minimize pollution, either water pollution or the air pollution. That is what we call green manufacturing. In other words, anything you do at all to minimize all this negativity can be considered as one or two concepts in green manufacturing. So, green manufacturing products do not harm customers, you that you are using it. It doesn't harm the employees, and it does not harm the environment. So you can ask the question, why producing this water? How much of the environment do we harm? Not only that, after you drink this water and then you dispose of the bottle, how much of harm does it cause to our environment? So these are all under green manufacturing. So globally, there have been a lot of investment in green manufacturing to ensure that we use minimal material, to ensure that we change our process, to ensure that we reduce waste, to ensure that we reduce environmental effects. Green technology investments has reached about $755 billion, although a country like Nigeria is still being left behind. We are also trying, but not so much. And out of all this, the electric vehicles and energy solutions have the largest share. In other words, the electric vehicles, when you talk about electric vehicles, you minimize materials. Not only that, you reduce the environmental pollution when you drive that. And then the energy solution, you talk about renewable energies. So when you use all those sources of energy, you reduce pollutions and then you enhance investment. So green manufacturing involves resource efficiency, as I said, optimizing raw materials, minimize waste. And how do you minimize waste? There are 3 concepts. The concept of reuse, the concept of reduce, and the concept of recycle. We call it 3R. What do I call it? 3R. And what do they mean? Reuse. In other words, if you buy this today and you finish the water, don't throw away the bottle. Take it home and take it to your tap and then fetch water and then use it the other time. That's what we call the concept of reuse. Don't make it a single time use. Then reduce. So reduce the amount of this. Reduce the amount of this that you have in the society. For example, instead of giving us bottled water, we can have, what do they call it? A water box, big one, and then you can have cup. People can come around and take their cup if it's not going to disturb what we are doing. And then the recycle. Recycle means what? After you have used it, find a way of taking it back to the factory as raw materials. That's what we call recycle. Don't just throw it into the society. Don't throw it to pollute our environment. Then life cycle assessment, somebody work on it the other time. So for you to have a complete green manufacturing and engineering, you also need the concept of life cycle assessment. In other words, right from the design stage. So you don't design without taking care of what happens after usage. Does it make sense to you? So that's what they call life cycle assessment. What happens when they were designing this thing? What happened during the production? What happened during the sales period? What happened after the water must have been drunk? Is that okay? So what happened? The whole things. So we don't want this to get to the environment. So you take the overall impact into consideration. And then the environmental friendliness about the biodegradable material. The lecturer talked about it a lot the other time. So in other words, green manufacturing involves the use of biodegradable material. So material that can do what? That can do what? Biodegradable material means what? Material that can degrade by microorganisms. So you put it in the bowls or anywhere, and then you come back after a few months, and then you don't see it again. Those are biodegradable material. But so many material that's being used for manufacturing, especially bottles like this, they call them non-biodegradable, meaning that they can exist for hundreds of years and therefore pollute our society. Then consumption of waste internally. You generate waste, and then you also reuse it within that community, within that environment. For example, the waste you have at home. For example, let's say your urine, your feces, and some other things can also be converted to greener energy. You can generate gas from them. So instead of you just piling it under the ground, then you can use a mechanical means of extracting the gas that is being generated within the soil system there. And also both government and private sectors are investing in GM in different ways, which we are going to be talking about. Now, next slide. The concept of waste. The concept of waste in engineering and maybe in sciences also. What is the concept of waste? When do we say, oh, it has a lot of waste? Oh, what you are doing has a lot of waste. What are we talking about? It means that there's some unproductive aspect of the processes. Unproductive aspect of the processes. It may just be working. For example, if I need to pick, if normally this drink is supposed to be here to serve me, and it is placed here, it will take me extra time for me to walk down here. That extra time that is taking me is a waste. It's a waste in engineering. We want to minimize all those things. Number one, overproduction. When you produce more than what is needed, what happens to it? What are the negativity of it? It's a waste. It may not go into waste, but because you are keeping it more than necessary, you are wasting money, you are wasting resources. And not only that, you have inventory. You are keeping it somewhere, isn't it? When you keep it for too long, you incur costs. Cost of inventory, cost of security, cost of somebody who will be looking after it, cost of all those things. So they all become waste. What about waiting? In the manufacturing process, if I have to wait for the next stage to happen, it's a waste. No, it has to be programmed, it has to be done in such a way the consequence is well aligned. There's no waste at all. So that once I need to pick this thing, it comes to me. I don't need to stretch my hand. And also motion, as I said, movement from one place to the other within the factory floor or within where you are producing, where you are manufacturing. Once you are moving more than necessary, that motion can be considered as what? As a waste. And not only that, transportation, movement from one place to the other. For example, if I say, okay, I'm going to give you 5 products, you will take one to somebody in general area, takes to somebody in Turkey area, takes to somebody in Oritanera area, somebody in Nojagbo area, somebody in high school, somebody in grammar school, about 5, maybe about 10 to 20 places for you to go. Then it becomes a problem for you to minimize the amount of distance you are going to cover. They call it traveling salesman problem. Where should I go first? Where should I go second? Where should I go third? Where should I go first? The whole essence is we want to minimize what? Motion and transportation costs. Is that okay? If you don't minimize that, if you don't optimize your traveling process, then you have a transportation waste. Where you need to spend 100 naira, you are going to spend 200 naira. That extra 200 naira that you have spent is a what? It's a waste. Do you understand that concept? And also rework. When the process is not well done, and then you have a lot of faults in your production process, then you have to do a lot of rework, a remodeling, okay, you have to patch it here, you have to patch here. That's what we call rework. And when you have a lot of rework in your process, then that leads to a lot of waste as well. And then, for example, let's say producing bottles. And out of 100 bottles that I'm producing, 20 of them are not good, are not suitable to contain water. What do we call that 20? It's a waste. In other words, you have to do green engineering as to minimize the amount of waste that we are talking about. Overprocessing is also another one. Now, next slide. Like what the previous lecturer said, there are so many environmental issues that emanate from manufacturing process. And why do we have a lot of environmental issues? You use energy to do a lot of products. As a result of consumption of energy, it leads to greenhouse gas emissions. So you have CO2. Just go to our industries. Those people who live around our industries, they emit or they inhale a lot of all these emissions, CO2, CH4, N2O, which are not palatable to the environment. The air pollution, the volatile organic compounds, SO2 and NOx, there are also other air pollutants. What about water pollution? What about water pollution? Anywhere you have factories and they are not well monitored, and consequently they discharge their wastewater into the surrounding. What happens to all the water in that surrounding? They become contaminated and become polluted. Not only that, hazardous and non-hazardous waste that you have all over the place. So many ways. Just go to Taki area, go to Jena area, or around your place. Look around and tell me whether you have one waste or the other around you. So they could be hazardous, they may not be hazardous, but they are waste. And once you have waste, they have negative impact in our society and the environment. What about depletion of water, minerals, and fossil fuels? They are all there. Go to where minerals are being extracted in some part of the Southwest, or you go to the Niger Delta, where oil is being extracted. What happened to the environment? What is the status of the environment? Deforestation. What is deforestation? As I told you about 30 years ago, if you come around Lautech, you see a lot of forests. The Adenike side, they are all forests. The under G, they are all forests. But today, what have they become? There's deforestation all over the place as a result of human consumption. Energy consumption. So if care is not taken, then we will continue to depend on fossil fuel. If the renewable energy is not harvested optimally, then we'll continue to depend on renewable energy, on fossil fuel. And when you depend on that, what happens? Greenhouse environment is being depleted. Next one. Now, one of the consequences of manufacturing or consumption is the municipal solid waste. Municipal solid waste. Just go to so many places in our societies, in our environments. Go to places like Ibadan and Lagos and look at how huge the municipal solid waste is. And what do we call municipal solid waste? Anything that we generate after use. For example, paper, unused paper, glasses that we don't use, paperboard, food scrap that we waste, the plastics, metals, rubber, leather, wood, and all of them. They are combined together to be called what we call municipal solid waste. And these are wastes that are generated from homes. And then they are brought together to form a very big chunk of environmental hazard. And I can tell you that globally, about 2.01 billion tons of waste is generated annually. And this is projected to grow to 3.4 billion by 2050. That's a huge amount of waste. Funny enough, only 9 to 12% of this waste is being recycled, meaning that all other, about 88 to 90% of the other end up in landfill, incinerated, or leaked into the environment. In other words, the concept of responsible consumption must come into play. And that's also part of green manufacturing. So when you produce, you generate waste. How do you manage the waste? Can you convert the waste to something else? It's also part of what the previous lecturer talked about. Look at this. Have you seen something like this before? Anyone? Have you seen something like this? Where? Where? Ibadan. Ah. Mi ò sọ bẹ́ẹ̀ o, ìwọ ló sọ bẹ́ẹ̀ o. Oh, close to your house, right? Now look at it. Will you be happy seeing this? Will you be happy seeing this? What is the effect of this? Or what are the effects of this? Look at the drainage. The drainage is blocked. So once the drainage is blocked, what happened during the heavy downpour? What happened? Flood everywhere, isn't it? Omiyale, Agbaraya Shobu, isn't it? That's what happens. Look at the bottom right. You have plastic on our waterway, on our water. What is the effect? The life below water. And what do we call the life below water? Our fish or marine animals. What happens to them when you don't allow oxygen to reach them? What happens to them? They do what? They die. So what happens to those who depend on marine life to survive? What happens to them? They are thrown out of job. They are thrown into poverty. Is that okay? The top one, top right. What do you see? Burning of municipal solid waste. So what happens to people around that area? They continue to enjoy, right? You love it. So we should do it around you, isn't it? So you can see what we call the reason why sustainable manufacturing is extremely important and why the concept of green manufacturing engineering must be put into consideration in everything we do, right from the design stage to the aftermath of usage. Now, that brings me down to the concept of, next slide, the concept of sustainable development goal. I know students in chemistry, they are so much aware of that. But I just want to put the concept of green manufacturing engineering within the context of sustainable development goal. There's hardly any part of sustainable development goal that does not require green manufacturing and green engineering. For example, no poverty, SDG 1, no poverty. If you go through the green engineering or green manufacturing, it will reduce the amount of poverty. What about good health, zero hunger, life below water, life on land, sustainable cities, reducing inequality, industrial innovation. So there's hardly any part of sustainable development goal that you look at that you will not see why green manufacturing and green engineering is extremely important. So it is all over, it's all over the place. So anything that you do at all, you know, within the concept of green manufacturing and engineering, we surely fall under one or two or more of the sustainable development goal. So let's now go to the innovative technologies, innovative techniques for green manufacturing. There are about 6 of them that I will be talking about here. 5 or 6 of them. The first one is additive manufacturing and sustainable materials. Additive manufacturing, just take hold of it. Additive manufacturing and sustainable material. The second one is nanotechnology in environmental sustainability. Nanotechnology, environmental sustainability. Nanotechnology, green engineering, and green manufacturing. The third one is, the third and fourth are very similar. Artificial intelligence, the former lecturer also talked about it. Artificial intelligence for process optimization and energy efficiency. And then Internet of Things and smart sensor for real-time monitoring within the manufacturing sector. And then the renewable energy integration in manufacturing. And then lastly, the simulation tools for design and life cycle analysis. Simulation tool for design and life cycle analysis. So I will talk about those those 5 to 6 concepts very, very briefly now. Now, number one, additive manufacturing. What is additive manufacturing? Has anybody heard about 3D printing or additive manufacturing? Do we have anybody among the students? Like the chemistry student? Maybe engineering student, of course, they will have the idea. But the young chemistry student, I'm not sure you have that idea. For you to produce, look at the, oh, sorry. To the right, you have 3 images, isn't it? The one at the center. Let's say you want to produce that in the workshop. What you do is that you have a material of a certain dimension, and then you take it to a machine to manufacture into those shapes, isn't it? You remove material from the side, from the front, from the back. We call it machining. And then at the end of the day, then you can have the shape that you want. Similar to what we have here. So it's been machined. Surface is being removed for you to have the final shape. But in additive manufacturing, the production is exactly what you want. You want this, you design it, you put it, you translate into code, and then you put it into 3D printer. 3D printer is a printer that will print real life objects, not printing on paper, but it will print real life objects. For example, 3D printer can print this microphone. What you need to do is that you sketch it on the computer, you convert it into a readable language by the machine, and then the machine can then use, if you want to use plastic or you want to use metal. So it will be like this. So it will be touching it and depositing metals on it until you have exactly what you want. Do we understand that concept? You want to produce, let's say you want to produce this phone like this, maybe the pouch of this phone. The first thing is you design it. In other words, you draw it to dimension. And then from the drawing, you convert it to a readable language. In computer science, we call it readable language. It's a language that depicts what you want to design, what you have designed, and then the machine can read it. You convert it to that language, and then you insert into the 3D printer. The 3D printer have what they call filaments. So the filaments, they could be plastic, made from plastic material. They could be made from metals. They could also be made from any other material, like concrete. So what happens is that it will read the language, and then it will be depositing. It will be deposited to form exactly what you are seeing there. It will form exactly what you are seeing there. For example, look at the first picture here. You see how complex the shape of that engineering component is. The 3D printer will print exactly like that. In other words, you don't need to remove any material out of it. You don't also need to add any material out of it. It will print exactly what you want. What will be the advantage of that? Can somebody guess? Can somebody guess what will be the advantage of that? When you produce exact shape of what you want, there will not be any waste. There will not be any waste. There will not be any waste at all. That is the biggest advantage that you have. Not only that, no matter how complex the shape is, you can produce it. When you take some materials to some shape to the machine floor, for example, mechanical engineering workshop, there's a limit to which you can do with those machines. They cannot create complex shapes. But in 3D printing, you can create no matter how complex the shape is. And therefore, you can reduce the amount of material that you consume. Is that okay? No matter how complex the shape is, you can also produce it. And therefore, you can also use a lot of material. Look at the bottom one, right bottom here. What do you see there? It's a building that is being 3D printed. How will you believe that? A printer can print your building. In other words, instead of waiting for months for you to complete construction of your building, a 3D printer can do it within hours, and then you have your building. How beautiful would that be? And then in such a case, the crack that we see on the wall of the building, the defect that we see sometimes will be something of the past. And therefore, nothing is wasted, time is being gained, and then no matter how complex the building is, you enjoy it, and then you can have it within hours. How beautiful would that be? That's green engineering. All right. As I said, the advantages, next slide. I said it, design freedom. In other words, no matter how complex the shape is, the sustainability, because you can use materials. Even waste material, you can use them. Some of our students are trying to convert waste plastic to filament that can be used for 3D printing. So the accuracy and efficiency, instead of you removing, as I said before, once you can design accurately, it is always about GIGO, garbage in, garbage out. So you draw accurately, you also produce accurately. Is that okay? And it will be so fast. If you can build a building within 1 or 2 days, how much will it take you for a real life building? And then it will also be very, very cheap. And there's no conflict on the feed, isn't it? Like that. Do not have something like that because machine is working. Now, another green manufacturing is plastic recycling that I was talking about. We have so much plastic around us, but it can also be converted. You can make a lot of money from it, isn't it? They can also be converted to so many products. So you can see, you can be engaged and then you can make a lot of money. I think about 2 months ago or so, I delivered a lecture on this plastic recycling as a gold mine. If you are interested and you are ready to do it, you can make millions from plastics because you have plastic all around here. But because we are university students, we cannot do that. We are first degree holders, we cannot do that. And yet people are making millions every day from plastic recycling. If you are interested, you can get engaged. And not only that, when you recycle plastic, you have so many lives. Maybe some of the things you are using, they are product of recycled plastic, isn't it? If I can break my plastic down to small pieces, is that okay? Then I can use it as a feedstock to produce more other things. So look at here. No, can you go next slide? So you can see, next slide. So you can see all this. They are made from recycled plastic. And I can tell you that as of today, some of the Western world are coming to Nigeria to buy our recycled plastic. So in other words, you can make a lot of money out of it. And then you can also use it to make some other products. Some of my undergraduate projects, they made a fan, they make small products from plastics. They recycle the plastic that we see all over the place. They gather it together, melt it, design a mold, and then they produce all those products. So soon as you will see a lot of products, you won't know that they are made from recycled plastic, but indeed they are made from recycled plastic. All right. Now, that is the second one is, next slide, is on the issue of nanotechnology. So when you say nanotechnology, what does it mean? I think the previous lecturer also talked about it, and then eulogize some of our senior colleagues who are working in the area of nanotechnology. Is producing materials, structure at nanoscale. And when you say nanoscale, 1 nanometer means what? To meter. 1 nanometer to meter. What is the conversion? What is the conversion? 1 meter to nanometer, or 1 nanometer to meter, the case may be. What is the conversion unit? 1 times 10 raised to power minus 9 meter. So how big is a nanometer? How big? Can you see it with your naked eyes? Let me ask you, can any of you plug just a strand of your hair? Just plug it and look at it. Plug one, just one. Ladies can do it easily, but the boys may be difficult for them. So if you do that, and then you look at the diameter of that hair, can you guess what the diameter of your hair could be? Can you guess what your diameter of hair could be? The diameter of human hair is within the range of about 80 to 100 micrometer. So it means that if you have a strand of hair, and then you cut it along the diameter, now you have, let's say this is the hair, like this, and then you cut it like this. If you cut it into about 1,000 times, then one of it is likely to be 1 nanometer. That tells you how small what we are talking about is. And what is the advantage of doing that things at that level? It means that you are working very close to atomic level. The chemistry should understand this better. When you work very close to atomic level, then the concept of bulk property will no longer be in existence. And therefore, the surface effect compared to the bulk will go up very, very, significantly. In other words, the properties that you have when you have bulk material means material at meter level, centimeter, big materials. Then the properties at nanometer become excessively higher than those at the bulk level. And therefore, the scientists, the engineers, they are now manipulating those materials for the benefit of mankind. So one of those materials is graphene. Some of you must have heard about graphene. CNT, carbon nanotube, they are all materials at nanoscale. And when you add those materials to any component, what you have is that, let's say you have a material with a modulus of, let's say 100, and then you add a small amount of graphene to it, that 100 can become 1,000. And yet, the size of the new material will not change. Let's say I have iron, aluminum, or steel of this shape. I take it to the lab, look at the property. I get 100 gigapascal. And I had a very small amount of graphene to heat, or CNT to heat. And I take the same to the lab. I can get 1,000 without changing the shape. And it is the concept of nanotechnology that makes our phone to be very small. About 50 years ago, what is the size of computer? Do you remember in your CSC 101? Were you taken through, generation of computers? How big were computers in the olden days? How big? As big as a big room, isn't it? So you can't go with any computer, isn't it? But look at your phone. Look at your phone. You can see a phone like this, and they will tell you that the storage space is 128 gigabytes, isn't it? Gigabytes. Why do we have this? It's as a result of nanotechnology. Is that okay? So they are reducing the sizes to something that is much more powerful. And therefore, you will continue to have something smaller and yet more efficient than they used to be. Are we together? Now, a time will come, and a lot of research is being done in that area. When you come to how many times do you wear your clothes before you wash it? How many times? How many times? I will be maybe 1 time, but our boys, maybe 3, 4, 5 times. Oh, worry, isn't it? I can tell you in the next 10 years, you will come from your house with 5 clothes to the university, and then you will go back after a semester for 3 to 4 months without washing them. How nice would that be? How nice would that be? So you continue to wear your clothes without washing them. Why do you wash them? Why do you wash your clothes? Because of what? Because of sweat, isn't it? Because of dust all over the place, because of dirty water and some other things. What you are saying is that the textile are being improved with nanotechnology so that they become stain resistant, resilient. So no matter how much stain you push into the cloth, it will just do as hydrophobic. You remember what they call hydrophobic? Hydrophobic means what? Doesn't like water. So the water cannot stick to it, isn't it? So also the kind of cloth that we are designing now. Is that okay? So no matter how in fact, if you take it, so you see no idoti, you know me agbara, stay. So sweat will not go into it, dirty will not go into it. So Kamama will every day and nothing will happen to it. And now we have here cars. We are working on paint, nano paint, so that when you paint a building or you paint your car, no matter how dirty the environment is, it will not stay. And therefore, the washing machine manufacturers, the car washing people, they will lose their job. One day, but there will be other alternative job for them, isn't it? So you have all this, and they have a lot of things from the concept of nano. What about nanomedicine? Now, for you to do any surgery within your heart, what do? They do surgery, they open your heart, isn't it? So now we are now having nanorobots. What will nanorobot do? Nanorobot will go into your body, carry out the surgery without any open surgery. How beautiful would that be? And not only that, in drug analysis, for those who depend on drug, maybe they take their drug once in a day or every day or every month, the drug is taking advantage of nanotechnology in such a way that you have control release. You take the drug today, you won't need another drug in the next 1 year. Why? Because of the control release. It has been programmed, it has been designed to be releasing small, 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 small. So those are some beautiful things about nanotechnology. So in environment, in so many places, you have that concept. Even in food preservation, you have all of them. All right, so the second one is the concept of artificial intelligence, you mentioned also, or Internet of Things. What do we call Internet of Things? You must have been hearing it, isn't it? Think about it. You are using washing machine in your house, and it is connected to internet. So from here, from your phone, you can start your washing machine, you can stop your washing machine right from your office. That is what you call Internet of Things, isn't it? Internet of Things. Or artificial intelligence that you can use for prediction, that you can use for so many things. So in industry, manufacturing industries, so you can now use all of them to predict maintenance and to reduce downtime. That's what you call preventive maintenance. But with this of artificial intelligence, you can know exactly when your machine will break down. And therefore, you can now prevent breaking down of that particular machine. Monitoring optimized energy consumption. Next slide. You are not going to the next slide. So it means that you can optimize the amount of energy you have in your factory floor. So if you are not there, the sensor will know that you are not there, and then the electricity will be switched off. You are not using this, the electricity will be switched off. You are not going to do it yourself. You are not used to that because the electricity in Nigeria is not regular. Not only that, the electricity is very cheap. When I was studying in Belgium, my kid knew it. Every other place, sitting room. That is energy management. But instead of doing it yourself, then you have an intelligence sensor that will do it. Once you are detected, if you go to some hotels now, you are entering their staircase. What are they doing? They are monitoring energy. They are optimizing energy. So in manufacturing floor also, that is exactly what we have to optimize this. And then to optimize supply chain and to reduce transportation bottleneck. I was describing you giving somebody something in Turkey, somebody in this thing. So we call it traveling salesman problem. So we want to reduce all this logistics. Forecast and manage renewable energy, identify emission source and reduce them. So AI can do all these things. And you can also use it to build automation and HVAC management. So the AC can control your AC once you are not there, or once the temperature drops to something, then it will switch off. Once it is below it, it picks up again just to minimize the energy consumption. The third one, or the fourth one, is the renewable energy integration. And what do we call renewable energy? What do we call renewable energy? Like what? Like your solar, like your wind, like your thermal, like your sawdust or biomass and all this. So what you are saying is that in manufacturing industry, instead of depending on the grid or depending on the generator, then we can bring in renewable energy. And why do we do this? We want to reduce the amount of CO2 that is being emitted as a result of depending on the grid. Where do we get energy from the grid? Either from the gas, from the turbine, where a lot of, or coal, where a lot of CO2 is being generated. So what are the advantages of this? Next slide. The first one is that it reduces carbon emission. As I said, it also lowers the energy cost. Currently, for you to use generator in your home, it must be powerful, isn't it? Because the cost of fuel is what? is humongous now. So in other words, people will now see solar as a very good alternative. Although the opening cost or the initial cost is huge, but at the end of the day, you discover that the price will justify it. Then increase environmental sustainability. In other words, no problem with the environment, at least for now. There will be problem later on, but because by the time you have a lot of solar panels that have reached their end of lifetime, where will you put them? That is another environmental disaster in waiting. Unless we start thinking about how to enable those panels, you are going to have millions of panels later all our society. So that is another focal point that we need to look about. Then the resilience to energy price fluctuation and supply disruption. What do we mean by that? Only the last thing, káwọn NEPA bí disco, can increase skinny, can increase per unit energy. But if you have solar or other alternative energy in your home, will the price change? No, it will not change. So that will prevent manufacturing company from doing that, because manufacturing, they spend a lot of money on the issue of energy. Then simulation tool, the last one here, the simulation tools. For those in engineering, even in chemistry and sciences also, you use a lot of simulation tools. For example, Professor Blamid did a lot of work in the area of drug modeling, where before you go to the lab, you can model what you want, isn't it? Subject it to a lot of virtual tests. So when you subject it to a lot of virtual tests, you can determine what is going to happen to it at the end of the day. So you can know how to manipulate the property and then be futuristic about what is going to happen. Now, for example, in mechanical, for you to do any design of building, design of machine, the first thing you need to do is to model it. Modeling means you get the physical shape. Is that okay? And then you subject it to a exact situation that the component will be subjected to during service. And then you can determine what happens to it. Is it going to fail? Would there be crack? Will stress be would the stress be higher than the strength of the material? So you can evaluate all these things. The AC can be modeled, and then you can see whether one or two AC will be able to satisfy this all. So you can do all those modeling. That's what we call the simulation tool. So you don't only simulate, you also test and you do life cycle assessment using all those software. For example, the finite element analysis can help you to simulate and optimize structural and mechanical properties. So you do it, you check those properties. Would they be able to work under that condition? If not, that means you need to change material. So you have access to thousands of materials. If I use this material, will my structure stand? If not, can I change it to another material? So in other words, what is going to happen? So instead of using real life example or real life object for test, you use virtual material for test. And what is the essence of that? It is very fast, isn't it? You can do your simulation within hours. Not only that, it is cheaper because you are working on computer. So instead of you building a house and start testing it, you can do it virtually. So it becomes cheaper, and then it becomes also fast. And then it leads to, instead of physical prototyping, you can do virtual prototyping, and then you can carry out. I think this is likely engineering, but for some of you who are in drug design and some other things, you can also find the software very useful. For example, the finite elements analysis, the computational fluid dynamics, and then environmental impact assessment. You should have this as well. Now, I think I have about 5 to 10 minutes to go. Government policies and incentives for GME. So let's look at the environmental. You see, there's one thing about Nigeria. We'll say we have a lot of environmental problems, but I can tell you that there are regulations, there are acts. And when you say acts, what does it mean? It means that the regulation that is passed by the National Assembly. Is that okay? That is, the member of National Assembly say, yes, we agree with this thing. For example, the Student Loan Act. So you say Student Loan Act. It means that a process that has been debated at the floor of the National Assembly, and they all agree with this, so they pass it and the president also signs it, then becomes an act. Is that okay? So I can tell you that all this environmental problem we are talking about, we have government acts for them. For example, National Environmental Standard and Regulation Enforcement Agency. The Federal Environmental Protection is just to protect our environment. But the question to ask yourself is that, are this agency working as much as we wanted? That is the question we need to ask ourselves. Where were they when our environment is being polluted with plastic? Where are these agencies when the municipal solid waste is blocking our waterway? Where are these agencies when our water, when our aquatic life are dying as a result of, plastics and some other contaminants? Those are the questions we need to ask ourselves. But I can tell you there are agencies. There are agencies and there are agencies that were established purposely for the protection of our environment, including the marine life and environment. So what are the incentives to promote green practices? The first one is tax incentive. Next slide. The tax incentive. Government is imposing a lot of taxes, but the new government is trying to reduce taxes on some materials. For example, you want to bring in solar panels, you want to bring any process or anything that will enhance green manufacturing and engineering, they remove taxes out of them or they reduce taxes on them. Is that okay? But if you are bringing in used cars, they impose heavy tax on it. Are you getting that concept? But any other thing that will support green manufacturing, they reduce tax on it. And then they also make fund available for those who are engaging in the business. For some of us who listened to President Tinubu yesterday, was it yesterday? Yes. During the live broadcast to the nation, he highlighted so many strategies to support businesses, isn't it? In the previous one, he highlighted a lot of tax reform for those in businesses to reduce the impact of the government taxation. So what are the challenges? High costs of equipment, lack of access to finance, lack of incentive, limited market. So you have a lot of them aspects that are bringing challenge, that are challenging. Challenges or barriers to green manufacturing. So those are some of them. If you don't have money, for example, you want to do solar system to your house, and they say you are going to need 1.8 million naira, and you are earning 100,000 naira per month. How will you get it? But if there is access to finance, for example, okay, we can build it for you, and then you can be paying 20,000 naira every month. You will go for it, isn't it? You want to build a house, a nice house, that is going to cost, let's say, 30 million naira, and your salary is 200,000 naira per month. When are you going to accumulate this money? But you have access to finance, you can get it. You want to start a business, and then you have access to finance. So with finance, they can do a lot of things. But when you do that, please ensure that you pay back. Nigerians are so notorious in doing that. People borrow money. During the COVID time, if you remember, government was giving loans by NARSA. They were giving loans to so many people. Now it is time to pay. People are no longer answering the government to pay their money. But whether they run, they fly, or they walk, they will pay the money because their account is linked to what? To what? The account is linked to what? BVN. So no matter any account you open under that BVN, they will take their money, no matter how long it is. And not only that, you will not be able to get loan for your education. If you are owing any money, you will not be able to get government loan to fund your education. So it's important when you have access to finance, make sure you use it judiciously. So, I haven't talked about this. Okay, next slide. I will quickly talk about real life example, Coca-Cola. Next. I'll just talk about two very briefly, Coca-Cola. So how does Coca-Cola ensure that they use green manufacturing and engineering in their company? Coca-Cola in Nigeria, not Coca-Cola anywhere. Number one, Coca-Cola use effluent treatment plants that the previous lecturer talked about. In other words, the wastewater they generate from their companies are either being recycled or are aquatic life friendly. And for us to be convinced that those treated water are good for aquatic life, they have fish pond. And the only water you have from the fish pond is the treated water. So if those fish can survive, it means the water is what? Well treated. So that is number one. The second one is that they are reducing the amount of water they consume by 20% due to recycling. The third one is that in terms of energy generation, they now use more efficient energy generation method that actually reduce the amount of carbon emission by about 10,000 metric tons per year. That is exactly what we want. We want to reduce the carbon footprint, despite that their production is increased by 66%. And then lastly, they also deploy about 2,000 solar PV to reduce the carbon emission by about 1,900 tons. So that is Coca-Cola alone. So you would think that they are not doing much in terms of green manufacturing and engineering or even green chemistry. I can tell you that they are doing some. Not only that, the plastic they use, they are now using materials that are reducing the amount of materials they use by 16%. So in other words, they were using 100 before, now they are using 84. So that means they can do more. Not only that, the weight is being reduced drastically. The PET weight like this is being reduced very drastically. And that is reducing the amount of carbon emissions. And also the chiller they use for cooling, they're also environmental friendly. So these are the concept of green manufacturing within Coca-Cola that are being deployed to reduce the amount of the carbon footprint around the place. So in textile industry, next slide. In textile industry is also doing a lot. Next slide. In textile industry. So instead of using cotton alone, textile industry, they are now using organic cotton, they are using bamboo, they are using hemp, they are using recycled fiber, they are even using plastic to produce fabric now. You recycle plastic like this to produce fabrics. Water management also, they are using waterless dyeing. Instead of using a lot of water, they are now using waterless dyeing to do their fabric. And also the chemical management, non-toxic and low income. They use also less energy for their production. And most of their products are also being recycled within the framework. And then the productions of switchboard in electrical engineering, the switchboard that you have all over the place. So a lot of green manufacturing is being done to increase the efficiency of those companies. And I can tell you that if you look at this graph, next slide. If you look at this graph, they are increasing the efficiency of their production after using the green manufacturing approach from maybe about 67 to 68% to something close to 87% because of that approach. So they are using their motion, they are using so many things, improving training, give award to those who did well, reduce, reuse, and recycle materials, optimize energy use, avoid waste, and then optimize use of lubrication. So they are combined all this to improve the efficiency of their company. So what is the future outlook? Next slide. The future outlook. I can tell you there's a lot of potential to upscale the green manufacturing and engineering in Nigeria. Everywhere you see, you can have one way or the other to upscale this thing. And there's also a lot of opportunity for investment in this area, and then opportunity for strategic transfer. For example, potential for upscaling. Given our abundant renewable energy resources, awareness of environmental issues, and the increasing demand for sustainable products, the following will enhance green manufacturing, government policy, investment in infrastructure, capacity building, and public awareness. If I know that what I'm doing does not support green environments, then I can change it. If I know that, okay, instead of buying this thing every day, I can just buy one, keep the bottle, and then reuse the bottle. So you are contributing to green environment. And also the investment opportunity are also there in renewable energy, waste management and recycling, energy efficient solution, water efficient technology. I can tell you that any project you do around this area will always earn you one kind of award or not, or it will be acceptable. If you do anything to improve plastic recycling, anything you do to improve plastic recycling, it will earn you an award. Last 2 weeks, we were in Lagos for a competition. The guy who got the award, you know what he did? Plastic waste, plastic bottle like this. Cut it like this, cut it like this, put some electronic gadget inside the very small one and produce torchlight. And the torchlight is sold for 350 naira. 350 naira. That means everybody will be able to do what? To have access to it, to buy it. Isn't it? The only thing is that once you want to charge it, you have to come to us to charge it. And you charge it for 50 naira. It will last you for 24 hours of lighting. Is that okay? So that is something else. So if you do something close to that, something more than that, you will also be awarded. You will also be rewarded for doing that. The strategic skip, I think the lecture, oh, we are no longer there. Industrial collaboration is there, as I said, industrial academic collaboration, vocational training. I want to advise you students. You see, anytime you have opportunity to learn one thing or the other, especially during holiday, don't just sit at home and be, on your WhatsApp for 48 hours. Learn so many things. You can learn a lot of skill even on YouTube, isn't it? You can do a lot of things with the phone that you have. So always try to learn. Anything that you do that does not improve your knowledge or skill, consider it as a waste of time. So ask yourself, so improve knowledge me, so improve skill me, so improve my ability to speak, so improve my thinking ability. If you don't have it in all those, consider it as a big way. So internship and mentorship is very important. In conclusion, innovative technology for green manufacturing and engineering hold the key to achieving sustainable industrial growth. By embracing eco-friendly practices such as renewable energy, waste reduction, sustainable materials, nanotechnology, Nigerian industry can reduce their environmental footprint and enhance resource efficiency. As the nation seeks to balance economic development with environmental preservation, this forward-looking initiative pave the pathway toward a greener, more resilient industrial landscape. With collaborative efforts from the government, private sectors, and society at large, Nigeria can accelerate its journey towards sustainable industrial growth and contribute to a more sustainable and prosperous future for so many generations to come. Acknowledgement. I want to acknowledge the organizer of this conference under the advisorship of Professor OOE Onawumi. Thank you so much for inviting me. The organizing committee, so much. You people are so wonderful. To the students, you have been so attentive. And I'm very sure sky is just the beginning. Professor Abdulhamid said it the other time that some people say education is what? Is calm. Do you believe that? It is not by any standard. It is not. You can become anything. I'm very sure that I have governor among you, governor of your state, and tomorrow president is also among you. So by the time you work so hard, you pray so hard, like the motto of my secondary school, work hard, pray hard, and keep straight. We know the meaning of work hard, isn't it? Pray hard, right? Keep straight, what's the meaning of keep straight? Be focused. And also, masimagomago, don't cheat. Don't also allow shortcuts in your life. By the time you do that, I'm too sure that the sky will be the beginning for you. May I also thank all the attendees and others. Thank you for giving me this opportunity.
Thank you very much, sir, for that beautiful lecture. Another round of applause for him, please. Now, we are going to entertain only two questions. Two questions. So if you have questions, can you please come out here?
Afternoon, sir. Thank you for the beautiful lecture. Good afternoon, sir, Mr. Lecturer. Thank you for the beautiful lecture. Really appreciate it. You say something the other time that there are policies towards all these environmental asides, but there were no implementation of those policies by the masses? Or maybe I know what was that. Do you have a strategy or advice for the government towards full implementation of those strategies and those policies? Thanks.
Another question? Yeah.
Good afternoon, sir. My question is that if we have AI doing most of the jobs like building houses, drugs, and everything, so what are we coming to school to do? And like if, for instance, if you look at China, they have machineries building houses within short periods of time. When they now come through, like when they go through tough weathers and everything just crumbles. So why? What are we doing in school?
All right, that's an interesting question. For the first one, the government and sustainable strategy of green manufacturing and engineering strategy. You see, government will continue to be government, isn't it? Government will have plan, solid plan, but when it comes to implementation, you will see something else. That is what happens in today's governance. Who knows what the problem will become one of them. And then those things that we think is not possible will become very possible. Isn't it? In other words, that is the reason why very knowledgeable people, those who have passion for development, should also be in government. And you also don't need to be in the top position for you to implement some agenda. Even if you are the HOD of your department, you are a leader of your organization. You are the president of ACS. You can also do little things. You can do community service, isn't it? You can enlighten people about things. So you don't need to wait for government. But all in all, we may say that government is not too effective today. Maybe tomorrow they will become effective. Maybe people like you also come into position and then ginger us, because you still have a lot of government agencies that are doing very fine, isn't it? We know a lot of them, like CHAMP is doing very fine. Like this woman in, what do they call it? Disaster management. I listened to her presentation yesterday. She's doing fine. So you have people like that all over the place. One day, you also come there, and then we'll also be able to judge you whether you are part of it or you are not part of it. AI, as I said before, AI will take a lot of jobs, isn't it? But the fact is that energy cannot be created, not destroyed, but can be converted from one form to the other. Is that not the principle of energy? Isn't it? That means energy will always be there. But the nature of energy is what we don't know. Isn't it? If you have rotational is mechanical energy. Isn't it? If you put it inside a rotor, it will convert it to what? Convert to what? Oh, but you also read physics now. You should understand what I'm saying. So if you have mechanical energy, you put it inside the rotor, it becomes electrical energy. Isn't it? If you have magnetic, you have conversions of all this energy. So the fact, let me ask you, how many of you still go to the phone booth to make calls? How many? Raise your hand. You still go to the phone booth to make call, or you go to the cyber cafe to browse? Your hands up. Nobody. What happened? So where are those people who were manning the phone booth? Where are they? Níbo ni wọ́n wà? Àwọn tó ní cyber cafe nǹkan níbo ni wọ́n wà? Can someone tell me where they are now? They have also moved. They have learned new skills and they have upgraded their skill. Is that okay? Don't forget all the hair we are talking about. Isn't it? Are they not big men today? Look at software. Some people do software, write software, isn't it? Some people write virus. Virus is just like a software, isn't it? And some people wrote what? They wrote what? Antivirus. Can you see? So there will always be jobs, but the nature of job will continue to change with respect to your skill. So if you feel that the skill you have now is okay for you, in the next 10 years, you will not be able to find job. But if you continue to upgrade your skill, there will always be job looking for you. I know some students, even undergraduates, are already earning 300,000, 500,000 naira per month. They are still undergraduates. You should know some of them. Isn't it? That's the kind of skill that we are talking about. So once you upgrade your skill, the concept of the fact that the machine will take your job will not even come to your mind. So skill upgrading is extremely important, and that's the only way to go if you want to survive in the modern world.
Thank you very much, sir, for doing justice to those questions. Now, I want to invite Dr. Mrs. Ibrahim to thank the lecturer on behalf of the organizers of this program. You're welcome, ma'am.
Thank you for giving me the opportunity to say the vote of thanks. But before I try to do that, Professor Asapa, thank you very much. We really appreciate you. And we do enjoy your lecture. In fact, let me tell you the reason. You know my system. I wanted to leave this place. As I was sitting at the back, so, hey, this is interesting. So I have to sit down. See, what I'm jotting. Because I love reading. But we start where the lecturer stopped. Thank you, Prof. Lecturer said that skill updating is very important. He said if you try to improve your skill, job will be looking for you. Wallahi, that's just the bitter truth. So I really appreciate you once again. Thank you for giving us that beautiful lecture. I like it. Then, you like to take something home. What will you take home? Anything that cannot improve your knowledge and skill is what? Waste of time. Thank you. God bless the organizer, the invited guest, PRO unit, myself, and all the students, the attendees. Thank you very much.
Now, before the next thing, I want to tell the part of the lecturer. I want 2 females and 2 males to tell us what he or she will be taking home. 2 females and 2 males. Your hands up. What you are taking home, or I should be pointing. Oh, yeah. 2 males, 2 females. Nobody? So you are not taking anything home? Eh? Chemistry students? You are not taking anything home? Ah. Is it too much? You are shy. You are shy. Well, if you are not able to come out, maybe I should just be pointing to you. Eh? Now, in the absence of that, now let me hand over to the advisor, Professor Mrs. Onohubi, to continue with the program.
Thank you so much. I want to appreciate all our speakers that have spoken before now, but we're supposed to have an lecture, but the lecturer is yet to be around, but that's not going to leave a vacuum for us. Now, you have been hearing about American Chemical Society. How many of you knows anything about it? The World American Society. Huh? Students, have you heard anything about American Chemical Society before? No? Okay, that is why I want to inform you what American Chemical Society is all about. You know, as the word connotes, American Chemical Society, that means is a society that is based in America and is responsible for all chemical related discipline. For example, chemistry discipline is there, biochemistry, chemical engineering. If you look at our audience, you will see that some people register from science laboratory, chemical engineering, chemistry to be precise, then biochemistry, and some other engineering courses. What is the work of this society? Why do you have to join them? What is the need for them? As we have American Chemical Society, we also have SCSN. No, I don't want to say student Nigeria Society. I want to, but maybe because I'm used to ACS, I'm used to American Chemical Society, but we have Chemical Society of Nigeria. Have you heard that one before? Of course, we all belong to SCSN, Students Chemical. You all belong to Student Chemical Society of Nigeria. So we also have Chemical Society of Nigeria. You see, those of you that are find yourself doing chemistry and chemical related discipline, it will be better if you belong to one or two of these societies. For example, you have a lot of things to gain when you join American Chemical Society as a student. They have a lot of scholarship, something that can support you as a student. For example, like next month now, we are already in August. This month, at California, they have from 13 to 17 of this month, which is August, they are supposed to be national meeting. They normally call it national meeting. It's supposed to be conference for all chemical related society that is being organized by American Chemical Society. Students are inclusive. So if you join, you have opportunity of going there, then you have a lot of network, you meet with different people. I could remember the first time, when I joined the society, I joined in 2015, and in 2016, I was opportune to travel to that place, to US for the national meeting. So they give, at times, they give the chapter, they give us grant to travel, but at least to encourage us. It will not sponsor everybody, but they give this grant to be able to encourage you. At least it can cater for your registration there. It will cater for your accommodation. At least 2 or 3 students can travel using this, but for accommodation and the transport. But you may, accommodation and the registration, but you may need to look for your transportation fare down to United States of America. That's that. Then, how do we join this American Chemical Society? So simple. Just, if you are really interested, you have thought it through, then go to Google, type American Chemical Society, then membership. You click there, it will show you, it will browse that different category of membership. We have student category, undergraduate, we have postgraduate, and then we have regular member, or the adults. Let me call that one adults. like those of us that have been working and that's regular member. When we have fellow, for you students, we have undergraduate category. And you will need, when you have filled up the application form, the membership form, then they normally take annual due, you know, since it is based in America, their due is in dollar. So, but they lower it for you undergraduate, at least. You cannot pay for undergraduate, you cannot pay more than $10, which is our money. Don't let me cover. Just say, you know, it's so simple. $10 is $10. For postgraduates, it can be up to, when they give you discount for undergrad, for postgraduates, you can be paying and $25 with discount. It is with discount that the undergraduate be paying for $10. But I think Nigerian chapter of the society, they did conference or symposium last month in which some of our members were represented. The Lautech branch member were represented there, and they, I think, nationally, they recognized Nigerian chapter, and they were given some discount for now by giving us a particular code that Professor Baleya is online now. He will tell us more about the code that we need to, instead of paying $10, it may lead to about $5. So what are the benefits that you stand to gain if you are a member of American Chemical Society? I've already told you, if you go online, you see a lot of benefits. Of course, I can point to about about 5 of my students that have graduated from being a member of American Chemical Society. Majority of them, at least they graduated with nothing less than 2-1. And the person that's supposed to speak with us, that I said is yet to be seen, is one of them. I pray that he will join us before we leave. And that his name is Victor Animation. Immediately he finished his service, he was employed where he was serving at a chem pharmaceutical. He was there. They were just, because they can see the talent in him. And the reason is that though himself is very good, and with his exposure through American Chemical Society, sky is not even the limit for him. He was so vast in all these chemical related things. And for those of you that are still doubting, especially those of you in 200 level, am I still going to change to medicine? I want to change to pharmacy. I want to change to nursing. I want to just to relax your mind. You are doing the right course, and that is chemistry. Chemistry is good. It's cut across every other discipline. You see, the last man that spoke is in engineering, and without chemistry, can we have any engineering? Without chemistry, can you have pharmacy? Without chemistry, can you have medical doctor? No. So chemistry is so central to all courses. And so if I were you, I just sit down, someone was asking, since artificial intelligence has taken over nearly everything, what are we going to be doing? Then use your knowledge of chemistry to be doing something meaningful, to be doing something different. So when you join American Chemical Society, you will have a lot of network, then you can benefit with scholarship. If you go out to their if you are able to develop innovative technology, innovative things, you'll be given award, you'll be given scholarship. So those are the things you are stand to benefit. And I'm calling upon us today that you be a member of American Chemical Society. Though you are, because you are now a Student Chemical Society of Nigeria, which is without any ado to that effect, since you belong to chemistry department, you have to belong to Student Chemical Society of Nigeria. And for those of us that are not really in chemistry, you are a chemical engineer, you can still join because the society is actually meant for you as well. So I believe I've been able to pass across something to you. God bless you. And if you want to join, you can, and maybe when you are checking things online and you are not really clear with it, you can just WhatsApp me or see Shego Joe. Here is it. Okay. And is the chapter president. But before I leave, I want to tell us that our chapter, which is LAUTECH chapter, was given an award. Our chapter, which is the LAUTECH student chapter. Our chapter, which is the LAUTECH student chapter, was given a commendable award because they recognize the work we have been doing among the students. And so our chapter was recognized, and this plaque was sent all the way from US. So the chapter. So let me just read it to us. ACS student chapter for dedication and commitment to chemistry and the community. The American Chemical Society presents the commendable award to Ladoke Akintola University of Technology International Student Chapter. Can we give ourselves a round of applause? So it's not for me, it's for all of us. So, and we are going to take photograph with it when it is time to take photograph. Thank you. Any question?
Thank you very much for your patience. We really appreciate the students. Can you give yourself a round of applause again? Thank you. Now, after the program, we are going to have photo section outside. So when we finish this program, now shall we all rise for our anthems? Let's be on our feet. Our anthems.
LAUTECH anthem. The national anthem.
Thank you very much for coming. We are still expecting you tomorrow morning